Okay, starting off lesson 4.4b. Our example 1, state the quadrant in which theta lies. Okay, at first, these problems look really complicated, but they're actually quite simple. All right, here's what you have to do. Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Okay, they say sine is less than 0. What does that mean exactly? Well, hypotenuse, or r, is always positive. All right, your opposite always represents your y value. Adjacent always represents your x value. Once again, hypotenuse is r. Okay, and I know hypotenuse is positive. So based off of this information, sine is less than 0. Less than 0 means negative, so the opposite must be negative, all right, in order for the ratio to be negative. And cosine is less than 0. So in order for this ratio here to be negative, that means adjacent has to be negative. So in what quadrant is both adjacent and opposite negative? That would be quadrant 3. X value is negative, y value is negative. You're in quadrant 3. Okay, that's all there is to it. Let's do another example. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Okay, and once again, h is r, a is x, and opposite is y. Okay, your r is always positive. They say secant is greater than 0 here, so your ratio has to be positive. And to make this ratio positive, adjacent must be positive. And then we have cotangent. All right, cotangent is less than 0. That means that the ratio has to be negative. Well, I already know from the previous piece of information that adjacent must be positive. All right, so if adjacent must be positive, then we conclude that the opposite must be negative here because the ratio has to be negative. It says less than 0. Okay, so in what quadrant is adjacent positive and opposite negative? That would be quadrant 4. Okay, that's all there is to that. If you need any help with this concept, just make sure to ask for help. On to the next example. Find the values of the 6 trig functions. Okay, so we have to use these two pieces of information together to determine where the triangle lies. Okay, cosine is adjacent over hypotenuse. The hypotenuse is always positive. All right, and in this case, 8 over 17 is positive, so adjacent must be positive as well. Then it says tangent is less than 0. Well, tangent is opposite over adjacent. Based on the previous piece of information, I know adjacent is positive. Oh, this is supposed to be an O here. All right, well, it says tangent is less than 0. The ratio has to be negative. So if adjacent's positive, that means opposite must be negative. So in which quadrant are you in then if opposite's negative and adjacent's positive? You're in quadrant 4. All right, then I label the side lengths. Adjacent is your x. Opposite is your y, which I don't have right now. And hypotenuse is 17. All right, I'll use the Pythagorean theorem. All right, to obtain what y is, it's 15. And be very careful here, this is what throws a lot of students off. I'm in the negative portion of the y-axis. Okay, so this value here is negative. All right, now you could answer your questions. All right, this is my theta. And inside here would be my reference angle, theta prime, theta with the apostrophe. Okay, so I have sine is opposite over hypotenuse, and this is adjacent. So opposite is negative 15, hypotenuse is 17. Done with that. Adjacent's 8, hypotenuse is 17, and tangent is opposite over adjacent. And in order to get the other trig functions, I simply take the reciprocal. So I have 17 over negative 15, 17 over 8, and 8 over negative 15. All right, that's all there is to it. All right, for the next one, tangent of theta is undefined. So I have opposite over adjacent. Now it says that tangent of theta is undefined. In order for a ratio to be undefined, 0 has to be under. All right, so you know you have 0 there. And adjacent is your x value, right? And on top, opposite is my y value. Okay, except I don't know what my y value is in this case. Then I have this constraint. All right, wherever my terminal side lands, it's going to land in between pi and 2 pi. All right, so here's pi, here's 2 pi. It's going to land somewhere in this region here. All right, where's it going to land? Well, x is 0. All right, this goes back. I gave you an example like this before. All right, if you're rotating, this is my terminal side here. If you're rotating, all right, what's happening to this x value here? Notice as the terminal side gets closer and closer to the y-axis, that x value gets smaller and smaller. All right, until you land on the y-axis and the x value becomes 0. So your adjacent is your x, which is 0. Your hypotenuse you could always call 1, or you could call it a million, whatever you want to call it. Keeping it simple, just call it 1. It's like your r. All right, and the opposite, notice that the y value here, it continues to get longer and longer until it matches up with the terminal side. Y equals 1. All right, but since I'm in the negative portion of the y-axis, it's going to be negative 1. All right. Even though these problems tend to be the easiest to do once you understand the underlying concept, students have the biggest trouble with this type of problem. So if you need any clarification, make sure to ask. All right, so I already have my x, y, and r values here, or my adjacent, opposite, and hypotenuse, so I could answer all my trig functions. So I have opposite over hypotenuse. I have adjacent over hypotenuse. I have tangent, which is opposite over adjacent. That's undefined. All right, and I simply find the reciprocal for my other 3 trig functions. Ooh, this one's going to be undefined because now the 0 is on the bottom. And this one's going to be 0 because now the 0 is on the top. All right, let's go on to the next example. Okay, for this problem, what do you do? Well, they give you the equation of a line, and they tell you what quadrant you're in. That's how you get your terminal side. So if I were to start from 0 here, I would go up 1, right 3. Well, in this case, I'm going to go down 1 and go back 3. All right, so there's my terminal side. That's how we get it. All right, so recall I'm going down 1, so this side is negative 1, and I went left 3, so that's a negative 3. All right, there's my right triangle. And then you use the Pythagorean theorem to get the hypotenuse, and you get square root of 10. All right, pretty simple stuff. All right, now my adjacent side, recall that I'm always using this angle formed by the terminal side and the x-axis. All right, it always touches the origin. And now I can answer all my trig functions. This is my x, this is my y, this is my r, or this is my adjacent, that's my opposite, and that's my hypotenuse. So now I can answer all these. I have negative 1 over the square root of 10. All right, I have to rationalize the denominator. So I have square root of 10 over 10. Then I have negative 3 over square root of 10. So multiply top and bottom by square root of 10, and I have negative 3 square root of 10 over 10. And then tangent is negative 1 over negative 3, so just 1/3. All right, for the rest, you could flip them or just do it the way we did the first three. So I have square root of 10 over negative 1. That's negative square root of 10. Then I have square root of 10 over negative 3. Then I have negative 3 over negative 1. It's 3. Alrighty, going on to the next example. Alright, this one's pretty much like the others. They give us two pieces of information, and we just have to answer this question. Alright, so cotangent equals negative 3. Alright, I could put that over 1. Cotangent is adjacent over opposite. So where's my adjacent negative 3 and my opposite 1? I would be in quadrant 2. Okay, pretty easy stuff. Alright, and because you actually could switch the negative up for these two values. Alright, but they tell you you're in quadrant 2. So here's my triangle. My adjacent is negative 3. My opposite is 1. You could use the Pythagorean theorem to figure out the hypotenuse. So this is my adjacent, opposite, and hypotenuse, or r, x, and y. Alright, cosine is adjacent over hypotenuse. So just plug in the pieces of information that we just acquired. And I get negative 3 over square root of 10. Okay, and that's all there is to that. Done. Alright, on to the next example. Alright, find two solutions of the equation. Give your answer in degrees and in radians. Okay, how do we get two solutions? Well, first of all, we have adjacent over hypotenuse. And hypotenuse is always positive, so that must mean adjacent's positive. Now, they don't tell you what quadrant you're in here. So, in what quadrants is adjacent positive? Well, it would be quadrant 1. It'll also be in quadrant 4. Okay? And adjacent is square root of 2. And hypotenuse is 2. Alright, now notice that if you multiply the leg, which is square root of 2, by the square root of 2, you get the hypotenuse. That's the property of 45, 45, 90. Alright, so trying to fit this in here the best I can. Alright, and since I have the degree measurements, alright, how do you figure out the two solutions? Well, the solutions are based on what theta is. Alright, that's what you're trying to figure out. What theta value gives you these triangles? Well, the first one would be 45 degrees. The next one would be what? You have to rotate all the way around, 90, 180, 270, another 45 is 315. All right, because this is where one terminal side is, and then we rotate all the way around and we get our other terminal side, 315. Okay, and I'm going to convert both of these into radians. So multiply by pi over 180, which gives you pi over 4. And for the other one, once again, pi over 180. And that gives you 7 pi over 4 when you simplify. Alrighty, and that's all there is to it. So if you have any questions, if you need any clarification, please make sure to ask. Begin the assignment at the bottom of the webpage.